Hi, welcome back to Layman's Guide to Cracking the Coding Interview. I'm Jox, and we have a yet simpler problem again. So this is the problem. We are required to find the last and the first positions of an element in an sorted array. So whenever you see this question, what comes into your mind? We have a sorted, you need to find a target. So obviously, I think everybody who knows that it's the binary search tree. So when it's sorted and we have to find the target, it's a BST obviously. And because we choose this because it's faster than other. So let's say we have an input of 133355666899. So this is the input and we have a target 6. So we are required to find the first and the last positions of the target 6. So here, this would be the first position and this would be the last position. So that means we have to return 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. So 6 and 8, right? So that's the positions that we need to return in this program. So it's a binary search tree, so it's quite common. Everybody heard about that and knows about that. So we have a starting point as a 0 because it's a 0th index, and we have an ending index as length of the input minus 1 because it's starting from 0. So we have to do minus 1 to get the length of the input with the index value. So that would be the 11 here in this case. And we have a midpoint. First we need to check whether the length of the input is 1 or less than that. In that situation, if it's an empty list, then we just simply return minus 1, minus 1. The question says that, but I think I didn't write that in detail. But however, that's the given. So in other case, if the length is 1, we need to check whether the value of the input, the value in the first index, 0th index, is equal to target or no. If so, then we just return 1 and 1. If not, then simply return minus 1 and minus 1. So we just need to return length of 2 array of two indices. So if that's not the case, we jump to finding the mid position. So this is the binary thing. So we have a mid positions of S plus length of the array, and then we subtract by the initial index and then divide by 2. So we do put doubles in order to get the integer, else we would be getting the floating point. So to avoid that, we have this thing. So in this case, we have a 5. So once we have a 5, 0, 1, 2, 3, 4, 5. So this is the midpoint. So we need to see whether 5 is a midpoint, 5 is a target or no. If so, then we just need to increment the midpoint in the forward direction as well as backward direction. If we have forward, then we increment the that value. If we have a backward, we decrement the value. So in this case, we would have this. But since our target is not 5, it's a 6. So we need to create a branch like this half branch and this half branch. So we have a condition here is a midpoint equal to target. So if no, then we're creating the two branches. The two branches would pass the parameter of the input and the target and the S, because we want to have the first half, right? So the first half, it's a S is a 0. So we have a 0 here, and we have a mid minus 1. So this was the mid. We don't need to care about the mid again because it's not the target. So we care about the half of that. So mid minus 1, and other positions, the other half would be the on the right hand side of this midpoint. So that would be the starting point would be mid plus 1 because mid is 5. So it should start from 6 to 11th. So this would be the 11th. So we iterate this process until we hit the target. So once we hit the target, so we have a yes condition here, then we have this thing. So if we hit the target, then we create a 2 pointer, I and j, passing the integer value, because sometimes target might just be a 1 value. They may not be like a 2 values, right? So if we just remove these 2, then we have a target 6. In this case, I and j, even if we decrement or increment I or j respectively, then we wouldn't have any changes in this situation. So in that case, we simply return 5 and 5. But here we have a 3, 6. So we can. So right now, I think the position would be somewhere in between here, because we have a second half, right? We partition that, and the midpoint could be right over here. I'm not sure. So if that's the case, then we have a midpoint here, and if we have it here, then we decrement the I. So we are decrementing the I. So is this still a target? Yes. So we decrement the I, right? Again, we iterate until we don't have a equals to the target. We don't have the input of the given point is not equal to the target. So if so, then we just decrement. So we decrement here, we decrement here, and here if we decrement, it's going to be 5. So this is not valid. So in that case, we just stop there. So we have it. What happened here? Let me clear this thing. Okay, so we have it. Sorry, I should be sorted. Okay, so we gonna be stopping here, and we also need to increment the j. So we try to increment the j, but the value is 8. So in this case, we don't have to do anything, and we simply stop there. And finally, we'll have a positions, these positions, and the last positions here, and program will simply return the indices of that 2 positions in the form of array. So the return would be simply, let me count here, 0, 1, 2, 3, 4, 5, 6. So 6, 7, 8. So program should return 6 and 8 as an array. So this is the return output. So let's go to the program, and I'll show you by debugging how it works, because I have already written the program. I just need to debug that. So here we have our program. Let me quickly run if this is okay. Okay, I put the target as a 9. That's why it's having the 11 and 11, because we just have 1, 9, and this is the last positions, and we have 11, 11. So let me put the 6 for this instance, and let me just run quickly. So we have a 6 and 9. With the input 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 4 fours of 6, so that's why we have the 6 to 9. In the earlier example, we have just a 3, so I had a written value of 6 and 8. So here it's a 6 and 9 because I added that. So let me put the debug point here so we could see how it goes. I'll call the debugger. All right, so into here, first it checks whether the length of the array is equals to 1 and the value within that is equals to the given target. If so, then just return 1 and 1, but that's not the case right now. Also, it checks another base case if the length is 1 but the value is not equal to target. That also could happen in some cases, and in that situation we just simply return -1 and 1. If that's not the case, otherwise we find the value of mid. So the mid would be the 5 as I mentioned earlier, and then we check the condition if that mid value is equal to target or no. So here it is not, so then we are branching into 2 halves, first half and the second half. So when we do the branching, we check whether the target is on the first half or the second half, right? So since it's on the second half, I think it's in the second half. Yeah, it's on the second half. So it will just go through the second half. We don't need to go to all the other half, because if there's no target, then there's no point of going there. So now we are on this half from 6 to 9. So here we'll also do the mid, and we have a midpoint as, because it was a 6 and 11, so the mid would be the 8. So we check if the target is equal to the array of that mid. So in that case it is. So we create a 2 pointer I and j, and we pass mid value to both of them. So now we are checking whether we're checking the condition whether I is greater than -1, because it shouldn't go less, I shouldn't go less than -1 and j shouldn't go above length of the array, right? So we have those 2 conditions, and also it should be if the target is equal to the value at that index. So if so, then we decrement the I. So it is, because we were at the 8 somewhere here, then we decrement the value, and still we check is it, and it is, so we're decrementing the value, and by here it's not, so it will not. It's done. So I think we reached here, and then it's not. So then now we are checking for the incrementing. Earlier we do the decrement, so now we are incrementing the value of j. Earlier was the I, and now it's the j. So we check whether the incrementing the j would give a result of target. It is. So we are here, I think. Where's j? Okay, 8. So we have a 9 as a j. So we are reaching somewhere around here. And it is, because now we are at this point, so we can't go any further. So we'll check the condition again. It is, it's not. So then we simply return I plus 1 and j minus 1, because I was decremented right earlier, even though the condition was not satisfied. So we have to increment that, and j was also incremented, so we have to decrement to reach to the current position. So our I was over here, so we have to decrement to tell the program that 6 was only up to here, and j was incrementing, so this was not true. So we have to decrement, telling that our target is just below that index. So we just written the I plus 1 and j minus 1. So we were here. From here it was like iterating, so it's a recursive function. So we are here again back. So now it can return the result. So we have a 6 and the 9. There you go. All right, so let me just run quickly. So we have a 6 and 9. So the runtime for this would be the obvious. It's the n of log n, because we just need to check the half of that tree. So it's just a log n. So thank you.